Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link data between CPU and expansion rack module. Okay, so before go to create the hardware configuration and testing with the program, I would like to explain the concept. So this is a picture of IM365 and for this one is IM365 receive. Okay, so why we use this module? Because if we have many I/O, it means that we have many module card input and output. It means that the rack that we can install here only 12 slot, right? Plus power supply and CPU, we have 12 slot. So if we have more than 12 slot, we need to use the extension rack module to extend more I/O by control with this CPU. Okay, so this is a concept why we use this module. So here just example, we have rack number 1 and rack number 2 here. Yes, number 1 and number 2. So this one linked by IM365 module. Yes, and we can see here we can connect with if we insert this module, this one will appear automatically. Yes, so if we have many I/O here and here, so we can extend, yes, the module. Okay, so it's very important. We no need to use another CPU or another memory. Yes, no need to install. We just install this module so we can link 11 rack more. Okay, 11 slot. Okay, and I will use SIMATIC Manager and Windows Flexible, yeah, to create the new project step by step, and then simulation with the Windows Flexible HMI. Okay, and I also use the PC adapter USB A2 for communication between my PC and PLC. Okay, so this just concept of how to link the data between CPU and extension rack module IM365. Okay, so it has send and receive, or we can send from here, also receive here. Okay, so let's go to our software to create the new project. So first I will insert one more folder, extension rack. Yes, and then open the SIMATIC Manager. Right now I will use version 5.6. Yes, so let's go to new project, and then this one example extension, yeah, IO, extension IO, right? Okay, and then browse to find the folder that we just created on desktop here, and then click OK. So we need to add new object, right? But before add the new object, let's set the temporary or PG defect. Yeah, let's see here is connect with the gigabit network. We call it is the existing project that we already learned about how to read data from encoder with the other CPU that use the LAN cable. So right now I will use the PC adapter USB, so we need to set the PGPC interface. Yeah, so go to option and then set PGPC interface, open it up, and then go to find the PC adapter USB A2 here, auto, and then choose the property, and we can start network detection, yeah, to test our connection that link to CPU working or not. Yeah, it's so like this, it means that it working because transmission rate here, it's MPI network, and this profile is highest address here. So we click OK, and then click OK, and then click OK one more time. Okay, so it means that we can communication. So the next step, we will insert the new object, SIMATIC 300 station. Yes, and then go to hardware configuration, right? Go to hardware. Okay, and go to the SIMATIC 300 tab. Go to rack 300 and then drag and drop the rail to the project. Let's see here, we have only 11 slots for rack number 0. Yes. So first, let's go to add the CPU type. Yes. Right now, I will use CPU 314C2DP here. And I will use version 3.3. So this one. So drag and drop to the rack number 0. So here is the address of this profit bus. Okay, and then we need to add the power supply, right? Let me add the power supply. So go to PS, this one, to slot number 1, and we need to add the IM365 send and receive module, right? And for the nameplate, we need to put the same as here. Yes, nameplate, because if we put the wrong, yes, the wrong part number, when we download, it will fall the CPU, right? So here I will insert here. So this one is 365 OBA 01 0A 0. Okay, let me go to the font. Yes, brand. So this one is this module. Yeah, so we need to add the same this one, otherwise it will not working. Yes, so 365 OBA01, right? So let's go to IM, yeah, IM300 here. Okay, this tab, and then go to IM365, right? And find the part number the same as I show. So the part number here, let's see, 365 OBA01, right? The same our part number OBA01. Yes. So this one we can drag and drop to the rack number 0, and we got like this. Okay, and we need to insert one more rack, right? For rack number 2, this one. Yeah, this one. And let's go to the rack number 1. Yeah, rack number 1 here. Okay, and no need to add the power supply or something here. We just add the IM365, right? So go to IM365. Yeah, this one. So drag and drop here. Okay, if we would like to add the power supply, we can add also. Yeah, if we have one more power supply, we can add also. But in this case, no need to use the power supply. So let's see here. If we add like this, it will connect automatically between IM365 send and IM365 receive. Okay, and if we click here, yeah, and click here, it will change for us. And for the address for communication is 2004. Okay. So right now we already link. So if we would like to send the data from here to here, yeah. Example, I will add the I/O, yes, one more for digital output module, yes. So I will go to SM300, go to DO 300, and I will use the module, this one, the same as my module 18801, right? 16, yes. So drag and drop here. Okay, we will got like this. And for the address, we can click here. We will know the address of this module. So address is start from Q32.0 until 33.7. Okay, 16-bit. Good. Okay, so let's save the project, and we need to download the hardware configuration to the PLC, right? So let's go to download button. Okay, click download button, and then select all. Click OK. It will detect the CPU. Yes. So click view to view the CPU. Okay, right now it detects one CPU. So we can download. Yes. Okay, we can click OK to download. Yes. And click OK to stop the CPU. Yes, CPU is stopped. And then finish. Click yes to restart the CPU back. Yes. Right now the I/O is not on. Yes, for all, because we not yet create the block for test, right? Actually, we can test directly from the blocks. Yeah. For example, let's go here for test, because we already know the address of this module and this module, right? For this module, I/O, it will start from I123.0 until I126.0.7, right? Because it's 32 bits for input on board with the CPU, and for the output is 32 bits. 16 bit. Start from Q123.0 until Q125.7. Okay. So if we know this address, so we can create the project, create the block for start and stop the I/O, right? So basically we can test like this. So let's go to block, and then go to PLC tab, go to monitor, modify variables, and then Okay, and then we can type example. I would like to for the Q123.0, right? Q124, sorry, dot 1, Q124.2, yeah. And then if I would like to for more output here on the rack number 1, so it will start from Q32.0, right? So Q32.0, Q32.1, yeah, like this. So I will set this one to 1 and go online, and then force. Let me show the status of PLC. It will turn on if we force the signal. Yes. So if we force the signal modify to 1, let's see the output is turned on. Yes. For point number 1. Yes. And if we would like to force for all, we can select like this. For to true, for to true, for to true, and for to trues. Yeah. We show it will turn on immediately, the same as the point number 1. Yeah. So we will modify this one to 1. Let's see. The output is turned on. Yes. Perfectly. Okay. So we can modify to 0. We can set 0, 0, 0, 0, 0. And then we can force to 0. It will turn off. The same time also, if we force to 0. Let's see. I will force to 0. Okay, turn off. So this just test the I/O. So if we would like to test many I/O, we can write more, yeah, for I/O. But we can create the block for test also. So I will cancel this one, and then go to blocks, OB1, and I will use data. Okay. So if we would like to start from the HMI, we can write, yes, I will write some command. Start and test I/O from HMI. So example, I write M0.0 and then send the output to the rack number 1 here. Yes. So rack number 1, it will start from 32.0, right, for output. So I will insert Q32.0. Yes. And then we can save, and then we can download. Yes. And then we can online. Okay. And we can create the sample project of WinCC flexible here for test. If we have the actual HMI, so we can create the project and then download to the HMI. Yeah. So right now I will use the Inti project. Yes. And then go to my HMI type. We can choose another type that we want. Right now I will use TP177B in color. Yes. Then we can simulation. Yes. So it's very important. If we have big plan, we can use a lot of I/O, right? So we need to extend the I/O because we have only 11 racks for 11 slot for rack number 0, and if we add more for extend, we can got more 11 slot also. Okay, so let's go to connection. Example, test I/O IM365, right? And for the driver communication, connect with the SIMATIC S7-300 400. And for this one, I will connect with the IF1B. And for this one, let's choose the 19200, yeah, for communication simulation. And this one I will use MPI, yes. Okay, and then we need to create the text for simulation, yes. So M, it will start the bit number 1, yeah. Example, go to the text and then go to text number 1. I will rename to be start bit 1. It is the boolean, right? So let's choose boolean and start from M 0.0, right? Okay, then go to the screen, and I will change the color of background of screen a little bit because I like this color, yes. And go to the button, yeah, example button here, so we can tie with the start bit 1. Okay, I will create one more for Q32.0, right, for show the status. So Q32.0, yes, it is the boolean, and for the address is Q32.0. okay, so we can go to the cycle, yeah, here. Okay, I will choose this one. And then here the color, I will use red color for status false or 0, yeah. If I start here, it will go to 1 and then change color to be green, right? So first let's configure the button. I will go to the click and then go to invert bit, because we need to toggle. When click, it will on. When click one more time, it will out, right? And then click the start bit 1, yes. And for this one, we need to show the color, right? So let's go apparent and then go to choose the text here, yeah, for status, and then choose bit. So when 1, it will change the background to be green, yes. And then we can save the project, save to put on the project that we already create here. So example, test IO IM365. And then we can simulation, yeah, let's test simulation, because we already online with the PLC, right? So let's simulation for test. it should be work if we push the button, right? Yes, let's test here. If I push the button, let's see the M0.0 is turned on. Yes. If I push one more time, it will turn off. Push one more time, it will turn on. One more time, it will turn off. Yes. Okay. So if we would like to test more bit, we can write also. Yes. So I will simulation. I will outline, and then I will insert one more network. Copy here. So this one we can mark as bit 2. This one bit 1. Yes. And here we can use example M0.1. Yes. M0.1. And this one should be Q32.1, right? Bit number 2. Yes. And if we would like to start this I/O, yeah, we can also start. So here it will start from Q 124.0, right? So example, this one we can mark as extension module. And I will insert one more network and copy here. So this one should be bit 1 CPU module, right? Because it on board the CPU module on board. Yes. So example, I will start from M 2.0, right? 2.0, and then start the Q 124.0, right? Okay, then we can save the project and then download to the PLC, and then we can online. Yes, and we need to create the start and stop from the HMI also, right? So let's go to create more text for HMI. We need to create one text more. Example, start bit 2, the boolean also, and it will start from M, right? 0.1 0.1 here. Yes. And for the stator, Q 32.1, right? Boolean. And for the address is Q 32.1. Yes. And one more for M02.0, right? This one should be start CPU bit 1. The address is M2.0, right? And for the stator, we can show here Q24.0. So Q124.0. And for the address, we start from Q124.0 also. and then we can go to the screen, and basically we can copy here. Yeah, for bit number 2 we can copy and then change this one, and this one we can copy also. Yeah, copy to here, and for button number 3 we can also copy here, and we just change to bit number 3. Yes, this one we can adjust to be aligned. Yeah, and for this one we can copy also here. Yes, and this one we can change the text only, right? So go to event, click, and then change to the text. It should be start bit 2, right? Here, enough. And for this one it will start from start bit 3, bit 1 CPU, right? Okay, and for the color animation we can change also to be, okay, we adjust align a little bit. Okay, this one go to color animation and just change this one to Q 32.1, and for this one should be Q 124.0, right? And then we can save the project, and we can online simulation. Yes, okay, so if we push, if we push the button start and stop the button, we can see the status of the PLC here. I will push. Yeah, if I push off here, let's see off here, it off. I will turn on this one. Yeah, the output is turned on. Start this one. Yeah, oh, this one I'm not yet change the status, right? So let me change the text a little bit. It should be green also, right? So green Q24, yes, it's correct, right? But why not green? Let's check the text. Oh, this one Q, no M, right? I'm sorry, I'm confused here. Yes, so change this one and then save the project again, and then we can simulation again. Yes, sorry, confused for the address. That's why it's not green. So right now it's green, right? Let's see here. Yes, it's green. So let me show the PLC again. Yes, it's green, and the output is on also. So if I push off, we can turn off from the HMI here. Yes, push off this one. Yes, push off this one, turn on this one, turn on this one, and turn on this one. It works perfectly, right? It means that the communication between the send module and receive module is working perfectly. Okay, so this is just an example, and if everyone would like to simulation another bit, we can simulation, follow my step. Yeah, we can connect to PLC, and then we can create the HMI project, and then we can test on and off the bit that we want. Yes, so it's very easy. If we have the expansion module for add more extend IO. Yes, so 11 plus 11 it will 22, right? 22 slots, so many IO that can use with this only one CPU. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye.